Okay, let's start with the graphical method. Can you close those windows? Next, put a heading now. Graphical method. So, how graphical methods are important for the graph? Now, can you switch on the slides? Switch on. Graphical method na will try to interpret certain information from the graph. Yes or no? Now graph, you know already graphs are how much important because in a graph I can see what is it I can see? I can see all the analysis I can see. Yes or no? For example, if I say like if you are doing any like for example you became a scientist, okay, and you are actually studying about the earthquakes, okay. Earthquakes will be what is it here? Suddenly they will rise and then they will shatter. Then they will rise, then they will shatter. Yes or no? So if I try to balance on the see on the graph, this is how it will be look like. And you are familiar with the ECG. Yes or no? Yes or no? In a hospital, they will take the some readings, right? They'll place something on the chest and they will actually take out all the readings. How your body is responding, how your heart is working and all. Yes or no? So that is all the information. By seeing that, the doctor can prescribe the medicine. Yes or no? Yes or no? But you are not the doctors, right? Who are you? Upcoming idiots. Okay? So upcoming doctors, yes or no? Chalo. So that's what. So you have to be very good with the graphs and where you can interpret the things. Yes or no? Even doctors also they'll see only the graphs, the the X-ray files and all they'll see and they'll prescribe right like that. So now even if it is like if I am talking about other things also it is important. Now whenever I say graph will be drawn on which how many axes it will be drawn by two axes. Yes or no? Two axis system you can say or else you can simply say what is that here 2D also you can say. Yes or no? In this one in a graph one quantity will be represented and one quantity will come because of the other two quantities. Am I correct here? Yes or no? So what is the meaning of that? Means for example, velocity is there, I wanted to get displacement by time. Means if you plot the graph between V and T, this will actually come. Yes or no? This quantity will be represented. But also other quantities can be also we can bring it up. So the graph can give you two things here. One is a slope as well as a area under the curve. Area under the curve, slope of the curve and area under the curve it will give you. Slope of the curve sometimes it will represent different quantity, area under the curve also represents a different quantity. Are you getting my point here? Slope of the curve na it will represent a different physical quantity. So here I can say it is a physical quantity 1, right now. What about this area under this one? It will represent a physical quantity 2. It represents what is it here? Physical quantity 2. So whenever I am talking about the slope of the graph, it will give you one physical quantity. Area under the graph, it will represent other physical quantity number 2 or no physical quantity also. Sometimes one physical quantity can be seen and other cannot be seen. Yes or no? So I can say slope of the physical quantity 1 or none also can be possible. Okay, here also physical quantity or none also can be possible. We all see all this graph. Why I need it? Because the motion in a straight line can be studied with help of a graphical method only. Yes or no? So we will try to use a graph. Based on that we will try to interpret a few conditions, right? And our main intention is to study the non-uniform motion, how you can actually do the non-uniform motion, governing equations and all we will try to study. So note down this one, the intro part. Last girl, what's your name, right? Niharshini, huh? What's your name? Yalini. Switch on the fans. Shall we start now? Sir, next one more point I would like to write here. So in the motion in a straight line, we have a certain parameters. Parameters means based on that only we will study the entire chapter. Okay. So parameters, what are the parameters we have it? Parameters na, we will have a initial velocity, we will have a final velocity, we have a acceleration, we have a displacement, we have a time. Totally how many parameters we have here? 5 parameters are there. Okay. So based on them only we will try to do the graphs. Right? The possibility graphs are, graph can be possible. What are the graphs can be possible here? Any two quantities you can represent on the graph. So for example, the main important is a displacement and a time graph, velocity and a time graph, acceleration and time graph. These are all important. And velocity and displacement graph. Okay, all those are there, we can actually do it. Okay, so the possible graph type is what is it here? Velocity and time graph, velocity and distance graph, displacement graph, and velocity and what is it? What is it? Acceleration is also there, right? Displacement, acceleration, and velocity also. Possible graphs I am trying to. Okay, so how to interpret this graph? How to identify this graph? We'll see. Okay, these graphs are important. Okay, shall I move on now? Okay. Now I will try to study the first type of graph, which is a VT graph. Okay, first let's see how it will be varying and what is important. Sorry, what is it I am trying to do? XT graph. XT means what is it here? Displacement time graph. So now possibility. Now I can draw one of the graph like this. Y axis I am representing with the x, and the x axis I am representing with the time t. Okay. Now, for example, that particle is varying the distance, like constantly it is varying. Na? For example, I'm trying to tell, because you know already graph from the lower classes. What is a graph now? For example, if I try to show you one small point here. This point here, this point is what is it here? They are starting points of 0, 0. Now we are let's say t1, comma x1. Can I write like that? Then other one is, other point is what is it here? T2, comma x2. Can I write like that? If I join them, what is it I will get it here? I will get one of the straight line like this. Yes or no? So in particle is varying its distance and time like that. Yes or no? Now, what I wanted to do is, there is a two things I have to interpret. One is a, first thing is that slope, second thing is the area under the curve. Slope na, this point is located, the time was here, what is the time here? T1. What is the time when it was reached this point? T2. Yes or no? You don't think that it is actually moving in a graph. It is not moving in a graph. We are actually seeing that how much distance and time they are varying. Clear? Now when was T1? What is the distance it was covered here? What is the distance it is covered whenever this one? X2. Got it? Now you want to get what is the first slope of the curve. Slope, which is nothing but what can I write? It is a tan theta also. Am I correct? Yes or no? Now slope in the sense, slope how do you calculate between the 2 points? We will take the difference in those points. Yes or no? Or else if you are familiar with the trigonometry, na, whatever angle here, same angle will be here, right? Yes or no? Yes or no? From the ground to here it was x2, means what is the value here? The ground to here, the value is x2, then this will be what is it, x1. This is a difference or not? X2 minus x1 or not? From here to here it is t2, here t1. So this is what is it here? T2 minus t1 can I write up? So tan theta will be what is it here? Opposite by adjacent. X2 minus x1 by t2 minus t1. Which means what is it here? Difference is nothing but can I write delta x divided by delta t. Yes or no? What is this one indicates here? Delta x by delta t is nothing but what? Delta x by delta t is nothing but what? Well, slope. But what is this quantity indicates? Velocity. Yes or no? Slope of this curve is what is it here? Velocity. Yes or no? Are you getting my point? So this delta x by delta t na velocity average graph is always gives the average value, which is what is it here? X2 minus x1 divided by t2 minus t1. Can I write like that? So I can write one more point here. X and t graph slope is velocity. Is it clear? Am I correct? Huh? Then what about area? Note down that one. Finished? This I indicate with the O, this I'll indicate with the some point P, this is the Q, let's say this is R. Done, buddy? Next, area under the curve. or curve. Area under the curve. Now this is the area, right? This is the area under the curve. I am trying. This is the area. Am I correct? So area under the curve from it looks like triangle or not? Triangle OQR. Can I write like that? What is the area? Buddy? Area is equal to half into height of that one is what is that here? X2. Yes or no? Base is how much here? T2. Product of distance into time. Is there any physical quantity it indicates? None. It will not show any physical quantity. Clear? No doubt. It does not indicate any physical quantity. Are you able to see board clearly? Yes, sir. Shall I? Next graph type. Appa? Performance. What are you doing there? Shall I remove this one? Now, similar manner, one more graph we'll try to study. VT graph. V means what is it here? Velocity and time graph. Imagine yourself, there is a one particle is there, which is actually moving in this manner. Okay, but logic you should understand. Velocity V. Are you okay, buddy? Are you okay? Okay. Now, for example, imagine yourself, there is a one graph is like this, VNT graph, and that graph is showing this sort of line. Okay. So now you know that this is starting point of it. Okay. Now, if I wanted to show any point here, this is a P point. Here it is a Q point, right? P point. If I drop down, this is the time when it was T1. Here, what is the time here? T2. What is this one? Velocity at this point? V1. What is the velocity at this point? V2. Clear? You're getting the same sense or not? So now same way. So now what I'll do? Now you try to see the points here. What is a P point here? Which is a T1 and V1. Yes or no? Here T2 and V2 according to us coordinates. Now what is the slope if I try to see? Now you know already if I try to extend this one, everywhere the point has the same slope. Yes or no? If it is curve, curve slope will change obviously. So you know already tan theta is nothing but it is a slope m. What is this one here? Slope m means here it will be v2 minus v1. Can I write? Here what is this one here? T2 minus T1. So v2 minus v1 na here opposite la v2 minus v1 and adjacent la what is it here? T2 minus T1. Which is nothing but what is it here? Change in velocity by change in time, which indicates which one? Very good. Acceleration A means slope of this curve will be what is it here? Acceleration. Means acceleration means this is the average acceleration. So, so what is this one here? Delta V divided by delta E. Right? Similar manner if I try to do area. Area I am trying to do. Area under the curve. You write down that one. of triangle OQR. What is the area under that? Area is equal to half into height is V2, breadth is T2. V2 and T2 indicates what is that here? What physical quantity? Velocity and time multiplication will be what is that here? Displacement. Yes or no? Velocity is equal to displacement by time. Displacement is equal to, but here the formula will look like what is that here? Half into V. Clear? It will indicate what is that here? Displacement. Product. Then Then now do it. So obviously what is it here? You will see that slope of the curve is what is it here? Acceleration. And the area under that curve. Area under that curve, na, this area, complete area, if I shade it like this, na, this area will be what is it here? Obviously it will indicate a displacement. Yes or no? So area under the curve is representing what? Different parameter, different quantity. Whereas slope is indicating what is it? A different physical quantity. Yes or no? Similar way, do it 80 by your own. Same sort of the graph you draw. Finished? So A and T, here the points are there. P is here T1, time is was here T1, acceleration was A1, Q, time is T2, acceleration is A2, drop down, here it is time is T1, T2, acceleration was V1, same tan theta or slope M, which is equal to what is that here? Same angle here. If I try to see the angle here, Angle was same. Am I correct? So what I'll get good? A2 minus A1 divided by T2 minus T1 delta A divided by delta T. Yes or no? This does not indicate any physical quantity. Am I correct? Slope of the curve is not at all giving any physical quantity. Yes or no? Wearing a, this is a delta change in acceleration with respect to time. Yes or no? So it does not indicate any physical quantity. It indicates what here? Yeah, variable acceleration. Then we'll mainly talk about what is it now? Area for this one. Area. Area under the curve. What is that here? From a triangle O, Q and R. So area is equal to what is that here? Half into this is area 2 into basis T. Tell me what is this indicates? Acceleration into time indicates what quantity? What is? Very good. It indicates what is that here? Velocity. Done? Okay. So you understood how to deal with the graph and all. So graph should be important for the slope and area, and based on that you need to solve it. Okay. Shall we do it now? So now we'll derive the governing equation by help of graphical method. Okay. Shall I? So just write down the heading now. Governing equation of motion in a straight line, equations of motion in straight line by graphical method. Right? So let consider a particle. Means particle means what is it, buddy? It can be a vehicle, it can be a living thing also, anything. A particle moving with constant acceleration A, and initial velocity U. Means you started observing that vehicle or the person. Okay, U, and a VT graph I am trying to draw. This is a velocity. What is this one here? Time. velocity in what is the units I can write is the units I am writing here, meter per second. Here the time is actually in seconds. You are actually calculating. Now the bodies already have some initial velocity. You have seen, like for example, the person is coming from somewhere. You have seen it. Like for example, this person is started moving from in somewhere like this. Okay, I don't know when it is when he started, but when he started, his velocity was 0. But whenever you are observing, who is observing here? Someone is observing it. So you are observing this person is actually walking with an initial velocity u. It's not velocity 0. He's moving. Now, when you see after some time, he was actually moving with some other velocity which is v, final velocity. Right? Are you getting my point here? So now the graph if I try to show, I will not show from a 0, but I will show it from the some quantity and it is varying like this. Constant acceleration. Right? So now initially what is this one? Here till here, from here to here, the velocity value is how much here? Initial velocity u. Now somewhere if I say for example, now here this particular point, here it was, what is the velocity now here? It has a final velocity, what is that here? What is the final velocity here? V. Got it? Now whenever you saw, the time was 0 that time. Now when you are seeing this particular point, the time was, what is it here? T time. Clear? Any difficulty? No. She is slowly going to the Dhanam mode. This lady. Are you going for Dhanam? Yoga is important, I know, but in not my class. Okay, draw this one first. Why simply they'll go in the Dhanam? In my classes like that, na. What about chemistry? English? Who is this fellow? Observer. Who is observing everything. Yes or no? Observer is a jobless fellow. Who will observe everything, right? Shall we? Now tell me, what is the angle it made in theta? Means can I calculate here to here how much time you have taken t time? Here to here how much? What is this one, Ray? This is a v minus u value only, no? Yes, I know. Now I am trying to write first slope, which is m, which is also known as what is it here? Tan theta. Also you know that v and t slope will be what is it here? Acceleration. Yes, I know. Which is nothing but what is it? V minus u divided by t, which is nothing but v minus u is equal to at. That is your first equation or not? Yes or no, right? Next, area under the curve. Slope though you finished, right? Now area under the curve, tell me. Now area under the curve, na, here it is very important. Next is a area under the curve. Area under the line. Na? This is the area or not? Can I say this is the first area? What about this one here? Second area. This is under the curve or not? Yes or no? I am writing area under the line, you know, right? That indicates what is it? Total area. Just now only we studied, right? What is the area under the BT curve indicates which quantity? Which quantity, right? Which quantity? Displacement. Very good. Total area. A is nothing but what is it here? It is a displacement. Yes or no? Yes or no? What is this one? Displacement. Then what happens now? Now area, triangle area plus a rectangle area. Can I do like that? Triangle area is what is it here? Half into base is how much here? T into height is how much here? V minus U. What about rectangle area? Half into U into T. That's it. Yes or no, right? The next situation, what happens here? So S is equals to half into, instead of V minus U, what can I write? AT can I write? Plus a UT can I write? So total formula is converting into what is it here? UT plus a half AT square, which is your second governing equation. Done? Is it okay? Shall I move on? Who is missing today? Ooty girl. What happened? Went to Ooty. She went to Ooty, I know. Okay, happens. Anybody feeling hungry? Ah, Amma, I don't have chocolates right now. Shall I move on next? Third equation also will derive and then go for line. Shall I? Chalo, let's. I am clearing all the stuff here. Shall I? Next, third equation how to derive now? We got already third. First equation is V minus U is equal to AT. First equation. This can be written as what is it? T is equals to V minus U divided by A. Can I write like that? Then second equation we have S is equal to UT plus half AT square, which is your second equation, right? Next situation, second in a first, so say first is substituted in second, you write. First is substituted in second equation. So S is equal to U into T means what is the idea? V minus U divided by A. Write along with me. A into T means what is the idea? V minus U divided by A whole square. So what happens now, which is equal to u v minus u square divided by a plus half into a into v square minus u plus u square minus 2vu divided by a square. This a and this a will cancel one time. From the both the side I will take a 2a common. S is equals to what happens here? It is 2uv minus a 2u square plus v square plus u square minus 2vu. So from this one what I can get is, I can cancel this one, and 2a that side if I take it now, 2a s is equals to v square minus u square L receive. That is your famous third equation. Then thank you. To finish, move. So tomorrow I'll conduct a test on the graphical method. Please learn and come. Listen. Then thank you. You can leave. Go for lunch. Leave, buddy. Whenever leaving, please arrange it and go.